to the second part of the first lesson. Now we open NetLogo. Also, NetLogo is an integrated development environment. Very powerful because in the shell of NetLogo we have both the programming tools and the graphical display. This is very interesting. This is our world. Our agent will behave here. And the first sheet is the interface. The second sheet is about information. And you are supposed to fill this sheet to cooperate with other people. No one is filling it. This is a rule for programmers. When a programmer, when a scientist has finished his work, the time for documentation does not exist. So, my line of work, I am always documenting my work while I am doing them. It's the unique possible solution. It's a constraint, sure. PhD students do that. And the third sheet is about coding. As you see, it is an integrated development environment, like either, the same. More powerful because we have directly here the display. You are not supposed to save, to run your construction, but it is safe to save, because if you have a crash in the middle of your work, you are losing your work. Very simple, absolutely simple, to have a cycle like for before. I create a few turtles. To create a few turtles, I have to create a block of program, a block of NetLogo. Usually we start with the block named setup. Now I enlarge. I have to remember how to enlarge. Zoom, simple. Zoom, control equal. No, it does not work. It does not work to enlarge because there is a problem of compatibility of the keyboard. Sorry for the question.
No, it's because I'm half blind. So you know
Two setup. Usually you can use any name you want, but usually we start with the setup name. Two is the construction of a verbal form. So if we are writing in English, this is directly a verb.
Sorry, in my PC, it didn't put the number to the line. So you have one in the first line. I don't have it.
Oh, this is an option I don't know where.
Okay.
But let's search.
Is it not important?
No, it is important because it's useful to have it. Can you help me in finding this option, everyone? Maybe is in this is Mac, so I have the preferences under the name of the program. But if it's not yeah, for me it's here. Show line numbers in editor. You see, but you found the preferences. Okay, very well. It is useful to have the number of the rows. To set up, it's like a verb. New line, indentation. But while in Python indentation is mandatory, here anything is optional. You can write a program on a unique row starting here and concluding about 1 kilometer on the right. It's not so easy. but NetLogo is written upon a wonderful language of the 50s whose name is Lisp. Lisp means least processor. Maybe is the most complicated creation of the computer scientist's mind. And it is for logic, it is a root of artificial intelligence, but the machine in the 50s had no power. So it was very difficult to build artificial intelligence tools, but if you study in your life Lisp, you can understand any language for easy. But the people writing logo were using Lisp, using, not proposing. And so within NetLogo, we have always the root of Lisp. The idea of Lisp is that you read from the left to the right. Very simple, as in a usual language. And in NetLogo, you read from the left to the right. You change row just to improve readability. Only for this reason. And also indentation is to improve readability. Leave if possible blank lines. You have not to pay for blank lines. They are free, but they improve a lot readability. If you imagine a block of 100 rows completely filled, it is impossible to read it. When I received from one of my students a block like that, I spent 5 minutes to add blank lines separating the different parts. Create what? What are the main object? Turtles, our agents. Create turtles. Oh, here there is a pronunciation problem. Turtles is the correct pronunciation, but if in the US they prefer turtle, so it is also a bit complicated. You are from the US,
Yes.
and your pronunciation is
Turtles.
turtle. You too, and maybe my friend are from another part of the US. Talking about the US is also talking about Finland and Sicily. You know, is a bit different. 5. And the block is finished. Automatically, my friend in that logo put end on the left, but just for aesthetic. Automatically. It is also using colors. You see, 2 and are pieces of that logo. And they are, I don't know, turquoise, don't know, green, what do you want? What I wrote, setup, is mine, it is black. Create turtles is a function of NetLogo. 5 is a number, so it is brown. If I see that something supposed to be a function is black, I have misspelled it. It is to be blue. This is simplifying our life. And how to run this piece of code? I create a button named setup. Easy. Okay?
So can you do it again?
I will do it immediately. I delete it. I delete. No more button. Sorry. Sorry, I was wrong. Delete. Okay. Here you read button, okay? Here. If you put the mouse within the window, you have a cross. Here is an arrow, here is a cross. When it is a cross, if you left click, no, sorry, right click, left click. Yeah, but I have to choose button, left click, and I have the button. Then I write the label. And the label is the same of the verb ordering the block to do something. Setup. This is the trick. You see? What if I press setup? 10 turtles have been created, 5 turtles have been created and placed in the middle of the screen. Okay? Can I be sure that they are 5 if I right click? Please stop me. Marco, stop me when you want.
Sorry about that. When I went back to code, it gives me a message saying nothing called create turtle has been defined.
You misspelled it.
Create turtles. In fact, it doesn't appear in blue.
You have here an iPhone?
Ah, no, I didn't put the iPhone.
Ah,
I have to put the iPhone.
just a detail.
Okay, thank you. So iPhone.
Marco without R is Marco. It does not work.
I know.
Professor are always distracted, you know.
Ah, turtles. Oh, I see. I thought of totally.
Turtle is very nice, but okay.
Thank you very much.
Nothing, but ask me, please. Always. Okay, so now with the correct code, if you press the button, you are creating the turtles in the middle of the word. Okay? Can I be sure that they are 5 if I press the right button upon them? I see that I have turtle 0, 1, 2, 3, 4. So they are 5. Okay?
Sorry, Peter, can I ask just a question?
Always.
Why they start with 0? I remember that.
This is a terrible idea of a computer scientist, counting from 0. This is simplifying the life of the computer scientist. Simply for that. Practically, a very few systems start from 1. Normally they start from 0. The first element is in 0 position. This is complicating our life because if I have a list of 10 elements, the last one is 9. I have to remember.
For example, in Python.
R starts from 1, while Python starts.
Yeah, also Fortran. R is based on Fortran. And so the idea being a statistical tool and being based on Fortran, if you recompile R, you discover that there's a lot of routine in Fortran. They start from 1. But all the modern languages start from 0. It's a pity. It's complicating our life. There is no reason. The mechanics. Marco?
So maybe I was asking kind of the same question. So why is it that there are 4, 0, 1, 2, 3, 4, and not 3 or 5 or another number?
No, we have created 5 turtles. Here, I order to the system to create 5 turtles.
Oh, yeah.
And the system is creating them with natural numbers, starting from 0. If I order to create other turtles, set up again, and I click again here, right click, you see that now we are going to 9. Okay? The number has a lot of interesting properties. Is the identifier of the agent, so it is also its address. And we can use it to communicate between agents. I will explain better this, but keep in mind that this number is very important. Okay? Is the who. Is the who. But the who is not only a name, it's also the address of the agent in memory. We will discover that this is very, very important. This word is very small. I can simply increase the number of pixels of each square. This is an example. If I put here patch size 25 pixels, And you see that now the word is very large. Too large, maybe. No. Let's use 20. It's better. Settings, 20. Ecco. Voilà. Perfect. Settings. In settings, but these are detail. Don't pay too much attention to details. I don't like to have all the turtles in the middle of the screen, so I want to move them. I need a cycle. Do I use for in that logo? Nope. We have two tools, while and for each, but is practically very, very rare the cases where we need to use them. Put in mind, this is a most important part of the conversation about that logo now, that you don't need cycles as for because you have ask. Ask is an operation of the observer. I am the observer. I look at the turtles and I ask them to do something. Okay? This is the key. If you don't forget that, you are able in programming in network. If you are in a construction creating an ask within an ask, pay a lot of attention. Probably you are wrong. This is Pietro's theorem. If you put an ask in an ask, probably, not sure, but probably you are wrong.
Every time.
Okay, it's simple. Now we create our ask to move. So second block, to move, okay, to move. I will create a button named move. If I create immediately it, I don't forget to create, but I receive an error message, end expected, sure, move need an end, but I am distracted, I don't create the end, I move to the interface, again, button, create it, move. The program is angry with me, it is red, because no move block exists. It exists, but it's not finished. So it is in error. Okay? Note that also code is red, signaling an error. Okay? To move. Oh, let's put the end. Check. Oh, wonderful. No more error. Key instruction. Ask. Turtles. The unique structure within a structure is open, close, square brackets. So open, square brackets. I am asking to each turtle to do something. Forward, no, better before to turn the direction. Left, so turn to the left of a random angle of max 359 degrees, because we start from 0. I can also write 360, but it's the same, it's 0. Okay. Then forward of 2 steps. Finish. Oh, wonderful program. But my purpose here is to show you the use of ask instead of for. Okay? Do you agree? Let's see the effect. Move. Oh, they are moving around. Again, 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 again. Okay. Marco, you saw?
Yeah, sorry, I didn't want to slow down everybody. I'm just doing something also.
You're not slowing down.
Move, not to move.
What the problem, Marco? I want to show you an interesting detail. Apparently, they are moving simultaneously, you see. But this is not true. They are moving in sequence. Marco?
I didn't want to slow down everybody.
If I slow down, you see, slower, slower, slower. Now we see that each turtle is moving in sequence. So the system is not parallel, sure. This is a sequential machine. And we have to keep in mind the order of the actions. NetLogo is implicitly reordering in random sequence the agents in each execution. So in the beginning of each ask, the list of the turtle is randomly shuffled. Maybe we don't want that. In this case, we have to use for each. But normally, it's good for us that the execution order is changing continuously. Ask.
So for each, so instead of using ask turtles,
Substituting ask, we will do that. Substituting ask with for each. And having the list of the total sorted, so ordered in some way. Maybe in increasing order of number. But only if I want that the sequence is always the same. Turtle 0 acting before turtle 1, acting before turtle 2, and so on. No, this is, sorry, it was for NetLogo.
Yeah.
NetLogo, for each, for each, for each.
We use turtles, then we sort, and then we.
For each. It's quite complicated, but we will have an example next lessons. Okay. Problems?
Yeah, I'm sorry.
No, with him.
No, me, I'm fine.
Okay. Marco?
Sorry, another problem. I have executed the command and all the turtles, they put themselves into an almost perfect circle, so not random like in your.
You forgot a piece of the code. You put this random here.
Random, yes, I did put random 359, left random 359, forward 2.
I think it's just because we make Tyson moving more than once. So if you give me another put the
Oh, I see. Okay.
The second time.
yeah, they will move the second.
But already the first time, if you start here,
Great fun.
you see that immediately they are putting them not in order. The angles are different. Okay. Anyway, this is detail.
I could spend half an hour having fun with that.
Playing with the turtles. And if I increase the speed again, we have the appearance of a simultaneously acting system. But this is not true. Okay? Stop. Finished. Now, the second part of the explanation, I go back to our content. Where is the content? Where are the contents? Here. We move to this couple of codes. Starting point example in NetLogo and starting point example in Python. Very important. Now, thanks for tons of questions.
Sorry, shall we say these sort of little
Example?
instructions that we've done now? Shall we say that?
No. You have now a very more significant example with this file. This couple of files are online or in Dropbox. I have them here in my computer, sure. But download them or keep them from Dropbox if you want to use them, please. First of all, start of NetLogo. Open. I discard what I've been doing and I move to my folder where I have agent-based models.
Could you say again where we find these two files that you pointed out before? The two files that we have to look at.
Sorry, I am looking again to the contents. Here you have starting point example and logo.
Yeah, where, in which directory did you...
They are online in lesson 1 in NetLogo or Python folder. Please familiarize a bit with the material. Ma just to be sure, have a look to the screen, please. I go to Terna to IT SIM 2018 and I have the 5 lessons, okay? Okay. Are you here? Terna to IT SIM 2018.
To IT backslash.
Sure. Okay. Marco, it's better if you follow me in the screen and we together will do this exercise after. Okay. Anyway, 5 lessons. First lesson, folder NetLogo, starting point example, right click, download with name, and you have it. Okay. If you have the box, you have it in your computer. Okay. Now, let me go back to NetLogo. NetLogo, the 5 lessons. First lesson, NetLogo, starting point. Here we have the program. Code. Oh, novelties. Clear all. The setup is cleaning all the content of the execution previously run, if any. Then we create turtles, and we decide to define their x, y positions, so horizontal and vertical, defining the x coordinate and the y coordinate in a random way. These are two NetLogo internal calculated values. The color is not blue, it's violet. It's a bit different. They are internally generated values, consistent with the dimension of the black area. If we have a lot of rows and columns, the random value will be consistent with this number of rows and columns. Okay? Automatically. Then we have a wonderful instruction. This is the order to switch on the clock. The clock is, the sound of the clock is tick, 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 tick. So ticks are the actions of the clock. Let's set ticks. We switch on the clock, putting it to 0. Okay? Let's see. Marco, are you here? Look at the screen, please. Set up. Oh, let me increase the size. Settings. 20 as patch size for me and not for you. Okay. You see that our turtles are around randomly because here, creating them, we decided that their position are random. Okay? Or usually we name the step of the execution go, but we can use any kind of name. This is usual. If you download a setup program written by someone, usually you find setup and go. Within setup, we have the creation of the word. Within go, we have the effect of the time. So pay attention. This is a loop about agents. Okay? This is a step in a loop about time. Two coordinates, the dimension of the agent, the length of the time. You have to keep this in mind because it is the key structure of any simulation program. The management of the time, the management of the agents. Move, talk. To move, ask turtles to increase or decrease randomly their positions. This is a trick. Random 3 is generating integer random number between 0 and strictly less than 3. Again, with Sandro, we will start always from 0. Strictly less from 3. So 0, 1, 2. If I subtract or I sum -1, the result will be -1, 0, 1. 0, 1, 2, -1, 0, 1. Okay? So our agents are moving. Or they stay in the same position or are moving on one step in up, down, left, right positions. Okay? Random walk. Do you agree? But within talk, within go, we have also talk. And in talk, we ask turtles to show Word is creating a sentence. Imagine to have a tool to create sentences, putting together different pieces of a phrase. X core, Y core. The result is go. These are the turtles. Sorry, it is not possible to increase the size of this part of the screen. I read for you. Turtle 7, 0, 8, 5, the new positions. Pay attention. Pay attention. The positions are not integer. They are float. Because when we create the turtles, we put them around randomly. And this kind of random calculation is floating point. So it is real, not integer. Okay? This random function is managing integer numbers. But here we have floating point number or real number, as you want. Okay? If I repeat, here we start from 7, I repeat, and we start from 6, and then 6, 5, 2, the first sequence was 7, 0, 8, because turtles have been reshuffled. Okay? What if I want to have a cycle upon time? This is the second key point about the cycles in NetLogo. The creators of NetLogo, I stress this, suggest us to run the time simply repeating the execution of this button. And we can automatize it with for error option. Now the button is a sign indicating the for error situation. If I press it, it is black because it is continuously pressed and our agents are moving around continuously. Okay? Please, any question?
It's not a question. Maybe the only thing is that we can add the tick in the two-block command.
Yeah,
Ticks now
this
are
is right.
zero.
This is a very good idea. Thanks, Sandro. I will reload it with the tick. Many thanks. Why this detail? Is not a detail, it's an important element. Thanks, Sandro. I will reload the file. I am asking to the clock to make a step. Otherwise, the clock is always to 0. You see, here we run a lot of time, and this is always 0. Instead, with the addendum of Sandro, now this is increasing, you see. At each step of the go, the clock is ticking. Okay, this is very important if you want to stop the execution. An example: after 1,000 ticks. Thanks. I will pay you a coffee. At least a coffee. Okay. Your question,
No, it was
Gabriele? Is right,
because
Gabriele?
regarding the random position of the turtle is caused by the random score. Because normally when
The initial random position is generated by this internal automatically generation number.
because after the random tree will not be float with the 0, 1.
Yeah, but this is an idea, but I can use a random float in another interval. Here I use random, but we have also the function of random float. I don't know, if I use a random float, I suppose that is written this way. Yeah, 100. No, 100 is exaggerated. Then we will have random float numbers between 0 and strictly less than.
No, it was just regarding the fact that when you use random score, you don't, it's always float.
Is
So
always
not
float.
be centered in
No.
the touch.
No. But you can, if you want, have let x score random 0, 20. In this case, they are integer positions. But it is complicated because you have to manage the dimension of the word. If you change the dimension of the word, the scale has to be modified. Instead, these two internal generating numbers know the dimension of the word. This is only the unique problem. Okay? Thanks. Other questions?
So random tree in this case is like move x square or x square minus 1 plus 0, 1, 2. Random number between.
In this case, minus 1 plus 0, 1, 2.
One of the randomly chooses one of the three.
Yeah, because random is generating random integer replies. Oh, just a detail. Why I have not been writing in this way? Or better, in this way. Sorry. Sorry. In this way. Why?
Probably because NetDogo first of all count 3 views 1 and then
Probably not, but I'm not sure. Probably not. But I am idle, so the idea of adding an open close parenthesis is not nice for me. I am not sure if minus 1 is calculated before the function. I guess the function is calculated before for Lisp reason, because random knows that as a unique argument, founding it, it uses it. So probably this is correct. But I'm not sure, so I write plus minus 1. Okay. I could also write in this way, another version. Sorry. Oh, I am distracted. It's already the same. Minus space 1 is the operation. Minus 1 is the value. It's a lot different. Oh, sorry, this is a special feature of NetDogo. Minus without space a number means the negative number. It's not the operation. The operation is preceding with a space. So 2 minus minus 1 means plus 1. Okay. Stop. Now we move to Python. The second feature of Python, that of using Python in a browser, interactive Python. But before doing that, the homework for tomorrow. The homework for tomorrow, it is not mandatory. If you do it, I will appreciate a lot it. Is this one. It is online. Familiarize with preparing two very simple. Very simple means 2-3 rows. Don't create a complicated tool. It's completely unuseful. Because what I ask you to have something doing the same actions in Python and in NetDogo. The same is the key of the exercise, not complicated things. And now I will show you the same in Python. The graphical output is not required because in my example now we will have a graphical output. Okay. Oh, now I start from Python. Oh, let enlarge as always. Now I will move a bit quickly and tomorrow I will repeat. Okay. This is simple starting point example. This is in idle. Do you remember the first way to use a Python tool, not interactively but via an IDE. Oh, finally. I have to create the turtles. Now I move quickly. Tomorrow I will repeat. I have to create the turtles, the class. Do you remember my explanations? I have to teach them how to move. I have to teach them how to talk. Tomorrow I will move here very slowly. But now I want to give you the ideas. Within the class, we have functions. Someone is naming them methods. A method is a function in a class. Anyway, they are functions. And with these functions, I am teaching to the class capital T to move and to talk. This is a very important strategy because if I have two classes, that of the firms and that of the consumers, each class will have different functions. And I cannot be wrong. I cannot order to a consumer to produce. In NetLogo, anything is mixed. You have no function specific to a breed of turtles. It is impossible. And this is a great limitation. Maybe the most important limitation. Then I run. I create an empty list. Don't fear, I am moving quickly, but tomorrow I will repeat. I am creating an empty list of turtles, and then I create 10 instances. This is an instance of turtle, and I put them in the list. The same that when I created the turtles in the NetLogo, adding them to the implicit list of the turtles. Create 10 turtles. They are in the list turtles. Ask turtles is the same. Then I have the goal. I am managing the time, and I order to the component of the list of the turtles to move and to talk. Reflect upon, it's very easy. I am sure. Now you are terrified, but you will discover that it is very easy. I create a class with its activities, this. I create the instances of the class, and I order to the instances to do something. Is it true? Sure, look. Turtle 0, turtle 1, turtle 2, turtle 3, and so on are in this position. Quite simple. Now, special effect. Drums. Special effects are do that interactively. In this class, I open a terminal. Each operating system has a terminal. In Mac, the terminal is named terminal in Italian, terminal in English, and so on. In Windows is named command prompt, prompt dei comandi, or PowerShell, the new terminal Unix-like. As I open a terminal like this, I can jump via the terminal to this folder. And as I am within this folder, tomorrow I will repeat. You are supposed to install Jupyter. I write Jupyter notebook and I open it as an example in Chrome or in Firefox or in Safari or in Edge. This is not important. Oh, wonderful. This is a browser, but this browser is containing a program. Run starting point example. This is our friend, the program we saw a minute ago. Don't look at this. Here you have the effect, the turtles and their positions. Okay? But I can, and this is very interesting, write the code directly in IPython. This is the same code we saw before. I execute it and I have the result. But I can also split the code. So the first part of the code is uniquely the class. This is doing nothing. This is generating the class. Nothing happens. The second part is the setup. Nothing happens. The third part is the go. Let go. As I repeat the go, look at the output. The output is changing, but the order is always the same. No random ordering here. Do you agree? Let's add a bit of graphics. Wonderful. We have here a magic command. %pylab means use the magic command to start the Py laboratory able in doing graphics. Inline within the browser. And the effect is magical. Is this one? Now the class has also the method plot. The effect is magic and it is this one. If I plot again, they move. Look at this. It's moving. The gray one, okay? Moving with small movement. And finally, I can add a shuffle. To shuffle a list means to reorder it randomly. And now the sequence of the actions is no more always the same. You see, 2, 3, 6. Repeat. 9, 3, 6. Shuffled as netlog. If you want to make me happy, I am sure, write 2 tiny codes, very, very small. I will do that for Mark. I will do your own work. I will do your own work. But you have to pay me. No, we will today. We will work together to do work. If you want to make me happy, please create 2 tiny codes and send it to me. But more and more, dedicate half an hour to explore this file. Tomorrow we will do that together, but the added value of having spent half an hour to work your head on it will be astonishing. Okay? See you tomorrow. Ah, just a question. Many thanks.
Regarding when we apply the method to the object, no? When we run it again, no? For
Yeah?
example, it takes the original,
No,
okay,
the last one.
the last one.
In memory, you have the.
It's in place equals true.
We have continuously the updated values.
Okay. Because normally in Python, for example, when we do an operation in a matrix, if we don't put in place equals true, then
If the name of the variable is the same, in memory it is in the same place. Here, I repeat this. This is important. Sorry. In this case,
yeah, they go exactly, no?
move modifies in each agent the x and the epsilon y.
Okay, yeah.
They are unique. Within each agent, there is a position in memory where we have these values. So when we do that again, the positions are the same, and we have the updated values. If I repeat setup, nope, I will start. Okay. Let's show a equal 1. Okay. A equal a plus 1, a 2 is the same. A is the same variable, so it is increased. You have to think about IPython as a unique execution. The environment is only one. Each cell is the same component of a whole. What's the problem?
No, it's fine, it's that sometimes when you apply a function to in Python, no? When you apply a function, for example, to a matrix, no? To an object, sometimes you have to specify in place equals true, in the sense that sometimes if it applies a function to an object, it gives you the results without editing that object in the memory.
Maybe we will discuss that. I don't understand your position. We will discuss. Now I save and then we discuss. End of the part of the first conversation.